Dear students, today we're going to focus on simplifying and solving algebraic fractions. So we're going to have two fractions involving algebra, two or more, and we need to simplify or to solve. I'm going to start from simplifying. Now, when you are simplifying an algebraic fraction, it's normal that your answer will be another fraction, a simplified fraction. For example, let's take a few examples and start working from here. For example, simplify number 1, a plus 3 on 3 plus a on 6. So, let's see, these are normal fractions. So as we've done in fractions, first thing that we need to do is to find the LCM. Now the LCM of 3 and 6 is 6. For 3 to become 6, I have to multiply by 2. So I have to multiply this by 2. So I have 2 bracket a plus 3 plus, for 6 to become 6, I'm leave it as it is, so plus a. I'm going to open up this bracket now. So I have 2a plus 6 plus a on 6. I'm going to collect like terms. 2a plus a is 3a. So that's 3a plus 6 on 6. But as you can notice, 3a plus 6 has a common factor, which we need to take out, which is 3 into a plus 2 on 6. And 3 divides into 6, divides 2. So the answer is a plus 2 all over 2. So as we've seen, I'm going to repeat. I've started by finding the least common multiple of 3 and 6. Then I made equivalent fractions here. Okay, so I left out 2 into brackets a plus 3 plus a. I opened up brackets, collected like terms, take out the common factor if need be. That's not always going to happen. And I simplified my result in the final part of the question. Let us see another example. Simplify and we have 2a plus 1 on 2 minus 3a plus 1 on 3. Now you have to be somewhat more careful here because you have a negative sign, and normally when we have a negative sign, it's easier to make mistakes. Note also that in exams it's usual to have the negative sign between the two fractions. So as we've done in the other example, I'm going to start by finding the LCM of 2 and 3, which is 6. So I need to multiply this by 3. So I need to multiply this by 3. And I need to multiply this by 2. So I need to multiply this by 2. So I get 3 bracket into 2a plus 1 minus 2 bracket into 3a plus 1. So opening up brackets, I'm going to end up with 6a plus 3 minus 6a minus 2 all over 6. 6a minus 6a cancels out. 3 minus 2 is 1. So the answer in this case is 1 on 6. So we've seen that in the first example here, we ended up with cancelling out a common factor. In this example, we ended out with just a value, a number. Let's make another example. Example number 3, simplify. A on 2 plus a squared minus 1 on 4a. Now this time we have also a variable in the denominator, so we have to include that in our LCM. So the LCM of 2 and 4a is 4a. So that this 2 becomes 4a, I have to multiply by 2a. So I have to multiply by 2a here. So I have 2a squared plus 4a into 4a goes 1, so that's times 1, a squared minus 1. This time I'm left with 3a squared minus 1 on 4a. And that is our final result. Now, examples can be even further, of having further difficulty. Let's write down another example, number 4, simplify. And this time I have 5 over 2a minus 3 minus 3 over 2a minus 3. As you can see, they have same denominator. So in this case, there is no need to find another denominator because they are the same. I simply need to add 5 minus 3. So I have 2a minus 3 is the denominator, 5 minus 3 is 2. And that is my final result. Another example. Example number 5. Simplify. 3 on 1 minus x plus 5 on 1 minus x squared. Now, this time we need to find an LCM. The LCM is 1 minus x squared. Why? Because 1 minus x squared goes into 1 minus x squared, and I have to square this to get 1 minus x squared. So the LCM is 1 minus x all squared. So I need to multiply this by 1 minus x. But if I multiply top and bottom by 1 minus x, so I have 3 into 1 minus x plus 1 minus x squared into 1 minus x squared goes 1. So plus 5. I open up top bracket, never open the denominator. So I have 3 minus 3x plus 5 on 1 minus x all squared. 3 plus 5 is 8, so I have 8 minus 3x all over 1 minus x all squared. As you can see here, there are no common factors in numerator. Always check that, because in case there is a common factor, you would need to simplify first to take out the common factor. Now, let's suppose we have a slightly harder example. So example number 6, simplify. X minus 1 all over 2x squared plus x on 3x minus x squared. Now, this time we have got another problem. Before finding the least common multiple, the common denominator, we have to make sure that there are no factors in the denominators. And this second denominator here, I'm going to highlight it. This second denominator has x, which is a common factor. So before starting, I have to factorize this first. So I've got x minus 1 on 2x squared plus x on x is a common factor, leaving 3 minus x. Now I can find the LCM. So the LCM this time is 2 x squared. X goes into x squared, so no need to write it down. 3 minus x. This is the highest common factor of all those terms. So for 2x squared to become 2x squared into 3 minus x, I have to multiply top and bottom by 3 minus x. So I'm going to have 3 minus x into x minus 1 plus, for x into 3 minus x to become 2x squared times 3 minus x, I have to multiply by 2x. So I have to multiply top by 2x. So I have x times 2x. There could be extra difficulty if we had a minus here, but this time it was a plus sign. Never open up the denominator, we're going to open up the numerator. So 3 times x is 3x, 3 times 1 is 3, minus x times x is minus x squared, minus x times 1 is minus x, plus 2x squared on 2x squared into 3 minus x. I am going now to collect like terms. I have 2x squared minus x squared is x squared, minus x plus 3x is plus 2x, plus 3 all over 2x squared into 3 minus x. Now, you have to be careful to make sure that there is no factors here. In fact, x squared plus 2x plus 3 does factorize. It becomes no, it doesn't factorize, excuse me. It doesn't factorize, so it's left like that. For it to factorize, we should have a negative sign there. So that doesn't factorize, so we leave it there. Let's find another example. So final example for now, simplify. 1 plus 1 on a plus 2 plus 4a on a squared minus 4. As we've seen in the previous example, a squared minus 4 can be factorized. That is a difference of two squares. So we're going to have 1 plus 1 on a plus 2 plus 4a on a plus 2, a minus 2. As we can see, a plus 2 is a common factor, so the LCM is a plus 2, a minus 2. So I have 1 on 1. I'm going to multiply 1 by a plus 2, a minus 2, so I have a plus 2, a minus 2. A plus 2 to become a plus 2, a minus 2, I have to multiply by a minus 2. So plus 1 times a minus 2 plus this is this, so plus 4a. I open up the top bracket. This is the difference of two squares, so this is a squared minus 4 plus a minus 2 plus 4a all over a plus 2, a minus 2. I'm going to simplify top, so I have a squared plus a plus 4a plus 5a minus 4 minus 2 is minus 6 all over a plus 2, a minus 2. This time, a squared plus 5a minus 6 does factorize, so we're going to get a and a. It subtracts, so 6 minus 1 is 5, plus 6 minus 1 all over a plus 2, a minus 2. That's the end of the problem. It could have been that one of these factors was a common factor, and in that case, I would have cancelled out. Now, that's how to factorize, how simplify algebraic fractions. Now, sometimes we would need to solve algebraic fractions. So let's see some examples about solving algebraic fractions. Now we're going to have a solution, one or two solutions, depending on the outcome while we're working. So this time the answer will not be another algebraic fraction. Even the method of working out is slightly different, because now we're going to have equations. So solving algebraic fractions. So let us see this. Let's start with the first example. Okay, start from simple examples, and examples will be harder as we go along. So for example, let's say we have solve 2x plus 1 on x minus 2 is equal to 3. As we can see here, it's a simple fraction. Okay, so I need to just take out this x minus 2 is being divided. I place it on the other side of the equation, and it becomes multiplied. So I have 2x plus 1 is equal to 3 bracket x minus 2. Opening up bracket, I get 2x plus 1 is equal to 3x minus 6. Placing x's on one side, numbers on the other, so I have 6 plus 1 is 3x minus 2x. So x is equal to 7. And in this case, we have just one single answer. Let's find some other examples. So another example, solve. And this time I've got x on x plus 3 plus 2 on x is equal to 1. Now, this time to work it out, we're going to use the following method. First, we're going to find what is the LCM. So the LCM is x times x plus 3. X times x plus 3. What am I going to do? I'm going to take that LCM and I'm going to multiply each of these terms, 3 terms, by the LCM. So I have x on x plus 3, x on x plus 3, multiplied by the LCM. The LCM was x plus 3 plus 2 on x. I am going to multiply that by the LCM times x plus 3 is equal to 1 multiplied by the LCM, which was x, into x plus 3. Now what's going to happen is that the LCM, the denominator, cancels out with one of the 2 terms, and I'm left with x squared plus 2 times x plus 3, so that's 2x plus 6, is equal to x times x plus 3, x squared plus 3x. In this case, x squared lies on each side of the equation, so we can cancel out x squared, so we're left with 2x plus 6 is equal to 3x, so x is equal to 6. And that had one simple answer. Okay, let's find another example. Let's work out another example. So I've got solve. One on x minus 6 minus 1 on x minus 2 is equal to 1 on 8. Now, the LCM is 8x minus 6, x minus 2. So I'm going to multiply each term by the LCM, alright? So I'm going to write it down again, 1 on x minus 6 minus 1 on x minus 2 is equal to 1 on 8, and each term is going to be multiplied by 8, x minus 6, x minus 2, so times 8, x minus 6, x minus 2, times 8, x minus 6, x minus 2. Now what happens is the denominator cancels out, x minus 2 cancels out, 8 cancels out, and I'm left with 8 into x minus 2 minus 8 into x minus 6 equals x minus 6, x minus 2. Okay, so I'm going to open up brackets. This time I didn't work it out immediately here because we had a negative sign. We have to be extra careful. So I have 8x minus 16 minus 8x plus 48 is equal to x squared minus 2x minus 6x plus 12. 8x minus 8x cancels out, so I have 0 equals x squared minus 8x plus 12 plus 16, which is plus 28, minus 48 minus 20. That factorizes, so I can factorize, that's a simple factorization, x and x, factors of 20, which give 8 when subtracted are 10 and 2, so that's minus 10 plus 2. So x is equal to 10, or x is equal to minus 2. Okay, so there we have another problem, and where this time we've got 2 different answers. Let's work out another example, slightly more difficult than this. So, solve a minus 4 all over a squared minus 16 minus 1 on a minus 5 is equal to 2. So this time as we can see, we have a denominator which can be factorized. So we have to factorize that first. So I have a minus 4 over a squared minus 16 is the difference of 2 squares. It leaves a minus 4, a plus 4, minus 1 on a minus 5 is equal to 2. As we can see here, a minus 4 cancels out, leaving 1 on top. Okay, so now we find the LCM. So the LCM this time is a plus 4, a minus 5. Okay, so I'm going to multiply each term by the LCM. So I got 1, a plus 4 cancels out, leaving a minus 5, minus, multiplying this by the LCM, a minus 5 cancels out, leaving a plus 4, equals to a plus 4, a minus 5. I'm going to open a bracket, so I have a minus 5 minus a minus 4 equals to bracket. I'm going to open up these two brackets first. So I have a squared plus 4 minus 5 minus 1. 4 times minus 5 minus 20. A minus a cancels out, so this is minus 9 is equal to 2a squared minus 2a minus 40. Minus 9 to the other side of the equation, so I get 0 equals 2a squared minus 2a minus 40 plus 9 minus 31. Now, as we can see, this time our equation doesn't factorize, but it can be solved. So we're going to solve that equation using the formula. Okay, so I have a is 2, b is minus 2, and c is negative 31. So I have x equals minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, I'm going to continue on this side of the board. So we've got x equals 2 plus or minus the square root. We're going to work that problem. So that's plus or minus 252 when you work out this sum 1 over 4. So I get x equals 2 plus root 252 on 4, or 2 minus root 252 on 4. And this gives the following answers. So x is equal to 4.47, or x is equal to minus 3.47. So as we have seen here, sometimes when we arrive at the last part of the question, we would need to use the formula to solve the quadratic equation. Okay, obviously that will have more marks. Now let's work out one or two examples where we would need to form the algebraic fraction first and then work out the problem. Okay, so we're going to have problems. So suppose we have the following problem. I drive 100 kilometers at x kilometers per hour, and then 60 kilometers at x plus 10 kilometers per hour. 1, write down an expression for the total time taken. Number 2, the total time is exactly 3 hours. Form an equation and show that it simplifies to 3x squared minus 130x minus 1000 is equal to 0. And number 3, solve the equation to find my two speeds. So that is our problem. We have to start from there. We have to start from what we know. Mela, we know two pieces, very important pieces of information. The first piece of information is I drive 100 kilometers at x kilometers per hour. And the second is that I drive 60 kilometers at x plus 10 kilometers per hour. So from the first part of the question, the one shaded in yellow, I know that the distance, so I'm going to try to work out the first part. The distance is 100 kilometers. The speed is x kilometers per hour. So I can find the time there. Time is distance all over speed. So the time it took me to cover the first part of the journey was 100 on x. If I consider the second part of the journey, I drive a distance which is equal to 60 kilometers at a speed, this time of x plus 10 kilometers per hour. So the time taken is again distance on speed. It's going to be equal to 60 on x plus 10. These are all hours, okay? These are all hours. So the total time taken is 100 on x plus 60 on x plus 10. As you can see, we have started forming our algebraic fraction. That's part 1 of the question. Part 2 of the question. I am told that the total time taken is exactly 3 hours. So 100 on x plus 60 on x plus 10 is exactly 3 hours because the times were in hours, okay? So that's very important. Now I formed the equation. I have to simplify to show that the equation is equal to this. So I've got also my answer. So the LCM in this case is x plus 10. Multiplying each one by the LCM, the first one, x cancels out. I'm left with 100 into x plus 10. Plus, eliminating x plus 10, I'm left with 60x. 3 times x plus 10. As you can see from here and from here, it seems to be correct. So 100x plus 1000 plus 60x is equal to 3x squared plus 30x. So 0 is equal to 3x squared. 30x minus 160x is minus 130x minus 1000. And there we have got our second part of the problem. Now for the third part of the problem, and that's correct, I have to solve the equation to find the two speeds. So I have 0 equals 3x squared minus 130 x minus 1000. Okay, now if you remember when we've done factorization, 1000 times 3 is 3000, 100 times 30 is 3000, so I got 3x squared minus 100x minus 30x minus 1000. If you find this part difficult, you can always use the formula to solve the equation, okay? So in that case, A would have been 3, B minus 130, and C minus 1000. I'm going to use grouping, so 0 equals x into 3x minus 100 minus 10 into 3x minus 100 So I've got a small mistake here. I'm going to correct my mistake because 3000 is also 150 times 20, and that's the correct one because this is a negative. So 0 equals 3x squared minus 150x plus 20x minus 1000. Excuse me for my mistake. I'm going to hurry up, and these things do happen. 0 equals 3x into x minus 50 plus 20 into x minus 50. So I got 0 equals x minus 50 into 3x plus 20. So x is equal to 50 or x is equal to minus 20 on 3. But since x was a speed, it can't be minus 20 on 3. So x is 50 kilometers per hour. So if x is 50 kilometers per hour, and x plus 10 is 60 kilometers per hour. Those are my two speeds, okay, for this problem. So this is the first problem. I consider this problem to be quite straightforward. It could have been worse. I'm going to show you another example of a problem which is slightly more difficult than this. So let's see another example. When the price of potatoes increased by 5 cents per kilogram, I could buy 10 kilograms less for the price of 36 euros. If x was the original price per kilogram of potatoes, form an equation and solve it to find x. Now, this problem is much more difficult because it is much less structured than the other one. You are not led to the equation. There is no equation. In the other example, I told you, show that it simplifies too. This time we have nothing, absolutely nothing. So you have to be very careful how to work it out. You have to understand the problem first. So I usually go to buy potatoes. I always spend 36 euros. Once upon a time, the price of potatoes increased by 5 cents per kilogram, meaning I'm going to buy less kilograms for the same price. From where am I going to start? I always tell you that if you draw something, sometimes it becomes much easier. So I'm going to draw the crate of potatoes. So I have a crate of potatoes. I'm not going to fill it in. What do I know? I know that when I usually go to the grocer, I read that it costs X cents per kilogram. Okay, so if I have 36 euros and it costs X cents per kilogram, how many kilos do I buy with 36 euros? So the number of kilograms bought, is the money I have, 36 euros. I'm going to change that 2 cents divided by the price per kilogram. So that's the number of kilograms of potatoes bought when the price was X cents per kilogram. What happened? After some time, I went again to the grocer, but this time the price was listed as X plus 5 per kilogram. So this time for the same amount of money, the number of kilograms bought is going to be equal to 36 euros. I'm going to change that to cents on X plus 5 because the price has increased. And these are the kilograms I am going to buy. Of course, this here is more because the price was cheap. So I'm told that I could buy 10 kilograms less. So the difference in kilograms, so 3,600 on X minus 3,600 on X plus 5 is equal to 10 kilos. That's the difference in the number of kilograms bought. And there you have your equation. Now we can solve that equation as usual. Okay, so the LCM is X plus 5. Multiplying by the LCM, I get 3,600 into X plus 5 minus 3,600 times X is 10X, X plus 5. Let's open up brackets. So I have 3,600 X plus 18,000 minus 3,600 X is equal to 10X squared plus 50X. 3,600 minus 3,600 cancels out. So I'm left with 0 equals 10X squared plus 50X minus 1,800. 18,000. I can divide this by 10 to simplify because 10 is a common factor. So 0 equals x squared plus 5x minus 1800. We can factorize this. If you find that 1800 is too big, don't worry, use the formula. So I have got x and x, 40 and 45 plus 45 minus 40, because 45 times 40 is 1800. So x is equal to minus 45, or x is equal to 40. Of course, you never go and buy something with a negative value, so this is correct, wrong, this is correct. So the price of potatoes was 40 cents per kilogram. And that is the end of this topic. Hope you have understood. Please see it again. Make sure you've understood every problem that there is in this video. Thanks for your attention.